Mitsubishi Heavy Industries, also with 40 years of experience in transportation, many projects. They are responsible for the whole scope of the project management, execution, manufacturing, operation and maintenance, installation, startup, all of the facets of that. So they'll also be engaged in this as well with us. And they have a full engineering team, and we have a core team that also is shared between the companies that's in Tokyo and our offices in Tokyo. Just to look at some of the products that Mitsubishi has: light rail vehicles, people movers, similar to what you see at some of the airports in U.S. cities, high-speed trains, some monorail. This one here is pretty different one here, a suspended monorail. And this one here is the HSST, which we'll talk a lot more about as we go through this. Looking at the scope of Mitsubishi's operations in Japan, these are many, and I'm not going to get too detailed here. I want to leave some time for questions. But many of the different types of installations and locations that they are in Japan. And also this includes many different types of transportation technology: monorail, suspended monorail, high-speed train, and maglev. The new way on maglev is something. International. We're also both companies are engaged in international transportation projects, and this is a list of some of the international projects that Mitsubishi has. And I'll point out here that these three projects are airport projects, but they're also what's called automated guided transit, which is kind of the classification of what the system would be here. These are airport installations, but these are people movers, but also automated guided transit. So similar types of train control and systems and processes that are required for executing this type of project. And you can see some of the other projects that they've had throughout the world. The development history of the HSST, it originally was started by Japan Airlines. So I guess hence you can get an idea where the original look here came for the first vehicle. And this is back in the 70s. And it has developed further in various stages through the 80s. In demonstrations and in actual projects where it's been built and shown and operated in commercial operation. And in 2005, the first commercial operation in Japan, in Nagoya, was put into operation. That's one we'll talk quite a bit about. But this is similar to the latest design of the HSST. Originally a high-speed surface transport, because there are versions of this that are a longer car that can go at very high speeds and been tested at very, very high speeds. What we're talking about is urban maglev, what we like to call urban maglev, which is about 100 kilometers per hour or around 60 plus miles per hour. So we're not talking about the very high-speed maglev, the very exotic technology, very expensive guideways, and very big safety concerns for very high speeds. HSST and the companies that have been shepherding this technology through its growth and development have also been involved in U.S. Research on this. We've been involved in the urban maglev programs in the USA, and none of these are active right now, but we participated in studies in the U.S. on urban maglev and maglev in general, including one in Colorado and another one in the U.S. That's, again, it's not active right now, but we participated here. Now, just spend a few minutes talking about the difference between the high-speed maglev and the maglev that we're proposing here. There are three types of systems that have been run in commercial operation. And of the three, two of the high-speed ones, one is in Japan, and not yet commercial, but this has been demonstrated, I should say. This is commercial. This one is commercial. This is high-speed. This is the Transrapid system. This is operating on a test track in Germany, and it's operating commercially in China. And it's planned for Munich Airport. And this is the HSST, which is operating commercially in Nagoya, Japan. So we'll talk a little bit about what the differences are here. I don't want to get into too many of the the major technical issues here. I'm not the technical engineer, and I don't think I want to get into that kind of discussion, but I want to talk about how our system is quite a bit simpler than some of these more elaborate things. And in this, in the Japanese system, you have superconducting magnets, and you have a lot of electrical gear that's on the wayside, that's actually on the guideway, built into the guideway. You have magnetics that are on the guideway. Same thing with the German system. So it's quite a more elaborate, expensive system. With our system, the HSST, we have what's called short stator, so that the motor itself and the levitation is all contained within the car. All it needs is the rail to operate with. And the rail, I'll explain to you how that works, is all that's needed to have the magnetic levitation operation, the motor and the levitation gear. So in this, the Japanese system, you can see this is on the wayside. So you actually have magnets that provide the lateral control and the force that keeps the car up in the air. That's along the wayside. That's both along the wayside. And same thing with Transrapid. In Transrapid, you have these here. This equipment here is located along the wayside, so that the motor itself is part of the wayside. Part of the motor is part of the wayside. Whereas with the HSST, all we have is a rail. If you see here, you'll have a guideway. You'll have some kind of a guide structure. You'll have this rail structure here. This is steel, and this part here is an aluminum cover that's on it. And the aluminum cover acts as part of the motor, the linear motor, and the steel shape acts as part of the U-shaped magnet. And the car itself has the magnetic modules. That's represented by this, and we'll show you those in some detail. And that surrounds the rail, which is a tremendous safety feature because the magnetic truck itself surrounds the rail, really can't derail. There's no way it can come off the rail. And everything is contained on the car. This little cartoon here represents, this spring represents the suspension of the car. The car never touches. It's always elevated by the magnetic field, and then the ride is also smoothed by these, what's actually air pillow springs that are on the car, an air suspension system. And again, this one we can more or less pass over this here, but this kind of just says that everything that happens in the motor is contained in the car, whereas on the JR and the Transrapid, part of the motor gear is on the wayside. This is a picture of the HSST in Nagoya. It's an operating system. It's been running since 2005. It was originally built as part of the purpose for this was for the Expo in 2005, and it did a tremendous job when we had this exposition. Up to 155,000 passengers per day rode this system. It's designed for 30,000 passengers per day, and right now is operating on this line, which is actually a hillside line. It's a very green area, very pretty area, and it runs from a subway station in Nagoya to a ring railroad. So it sort of serves the purpose of connecting those two locations. I want to talk a little bit about the guideway here. This guideway is a little different than what you might have. So we have a pier, and we have what essentially is like our sleepers. These here, what we call sleepers in a railroad. This would be the equivalent of that. And then you have these steel rails. On top of that, there's a little aluminum plate. That's all there is to the guideway. The system here is the spec, and the requirement is there'll be dual-lane guideway, and that's what this would, the way this would be built. It's dual-lane guideway. The module itself, the car that we propose here is what we call the L car, the longer car. Each car would have 5 modules on the side of the car, on each side of the car. So the module on each of the cars. There's 5 of them along the side of the car. The propulsion concept, and this will show you how it works here. We have a coil. This is part of the car surrounding the rail, and we have an electromagnet. You run a coil through here, and you create that electric magnet here. You create an attractive force to have a U-shaped magnet and an attraction to the rail itself. And that's the concept of levitation. So we have a current, creates a force, which lifts the car. So it lifts essentially attractive force for this that's coming surrounding the rail, and lifts that up, and with that it lifts up the whole car. So with that attractive force, if you had no other control, it would just come together with the rail. So what we have is we have our control, our gap sensor, which maintains that gap at about 3/4 of an inch, 8 millimeters gap. And that's the sort of the technology, the high technology that's in our system, is that gap control and that sensor to make that 8 millimeter gap. In addition, our system is very simple. Some of the high-speed systems have wayside magnetics that keep the train from hitting the side or from moving side to side. In this case, if we go around a curve and we have the force of the car moving to one side or the other, the gap will widen, the magnetic control will increase, and it will bring the car back to the center again. So that 8 millimeter gap is maintained, and it also maintains the lateral control as well. This is what one of the linear induction motors, and this is the magnetics. This is what's called the linear induction motor, and I'll just give a short explanation of that. This is another side view of the modules. So just the motor itself, just a short explanation of this. Maybe you're familiar with electric motors. You set up a magnetic field, you have a cage or a stator, a stationary portion, and you have a rotating portion in the center. So the magnetic field is set up, you have changing magnetic fields, and it chases around, and it creates the circular motion. That circular motion has to go through a gearbox, and then has to be transmitted to wheels. That's what you have with a typical train. So you have the issue of gearboxes, wheels, wear, recutting wheels, all those things. Here we have a linear motor, so that the stator is, let me back up one here. If you just picture this being straightened out, this primary coil, and to the primary coil and the reaction plate, which is that aluminum plate on top of the guideway, that becomes part of the motor. So you actually have a straight line motor, and you create the magnetic field in that aluminum plate, and you create a force by the modules in the car, changing the magnetic field in the modules on the car and creating that attractive force that runs in a straight line. So it's called linear induction motor. So we induce the magnetic field in the wayside or in the rail, which gives you the force to move the car forward. So the S vehicle, this is a smaller one. This is order of magnitude about 60, 70 people per car. It depends on how many seats you have in there, whether you have standees or seats. The one this has 3 modules on each side, 3 of these magnetic modules. And then there's the L car, which has 5 modules on each side. And approximately 100 people per car. This has 110, and that would be maybe more, very few seats, and maybe more, the densities might be more like what would be, say, used in Japan. Used here.
Excuse me.
And also the gradient here, we can make a 7% grade. So the spec in this thing here is a 6% grade. We have no problem with making that. It's a very good hill climb. Curve radius, we show here 50-meter curve radius. This, of course, depends on the actual alignment and what's there. And that also has to do with passenger comfort, too. Just because you can make a 50-meter radius doesn't mean you necessarily want to build it. You may not be comfortable riding in that kind of radius at higher speeds. So advantages, it's safe, it's comfortable, there's no risk of derailment. There's very little noise and vibration. There's no wheel connection, there's no wheel squeal. There's no rubber tires that wear. It spreads the weight of the car over the 5 modules, so it's very efficient in terms of how you can build that guideway. We can run in snow, not much of an issue here. We have a maintenance-free guideway with very much less rotating parts. Talk a little bit about this OMPO Courier line, and I'm going to try to show you this 5-minute movie of the line actually in operation. This is the system in Nagoya. This is sort of running through the yard in the shop. So as we said, this one's a little hard to make out here, but we're going from the subway to a ring line that runs around Nagoya, and it's going up a hill on this one here. So the OMPO Courier line is going up a hill on this. And the very first part of it goes through a tunnel, and I'll show some pictures on that one. We don't have that issue here, but it runs through a tunnel. Total is it's 9 kilometers long. The tunnel section is 1.4 kilometers, only 1 station. Elevated 7.5. 9 stations, 6% grade. Minimum radius there is 75 meters. There's really no sharp curves in this one here. Very nice, very smooth ride. And 100 kilometers per hour is the top speed. It's run with a headway of 6 minutes and peak time 10 minutes off peak. Could be run much quicker if you needed more trains or more throughput. This just really just shows the layout. 1 station in the tunnel, and then 6 stations along the line, and then there's a turnout that goes to the vehicle depot, which is something similar to what you would have here. This is the Linamo setup, not exactly what will be proposed here. Be a little different what we respond in our RFI. It's an aluminum alloy welded body, advanced car body. It's a linear induction motor. There's 10 limbs per car. It's latest solid state electrics as far as the inverters that are used for the power. That's all that means. The primary brake is electrical, so that when the car brakes, instead of using power to create that forward propulsion, the propulsion is then the momentum of the car is turned back into electricity and put back into the system. Very slow speed. We have a mechanical or hydraulic brake. That's the only thing that really touches the rail is that slow speed brake. And also the power chute that comes, it brings power to the car. And it's also a driverless system. We call this ATO, but we have all of the systems that are associated with automatic train operation or automated guided transit. Here's a picture of coming into a station. This is a picture of a switch here, how a crossover goes for the system. There's some pictures in the tunnel. There's a switch in the tunnel. And here's a station approach here. And some other photographs along the line. Now I wanted to make a comment about this guideway here. This was built in Nagoya as a public project, and the guideway itself was designed and built for any train, any train that was considered for this project. So that this guideway is far more massive than what's required for this train. So a concrete and steel guideway, more like what you'll see in the brochure. I can pass some of those around, what we'll see in some of the other things. Don't necessarily have to have this kind of massive concrete guideway. And this is in a very, very heavy earthquake zone, by the way, in Japan. This is the depot. Shows you switches that can be used in the depot, where you have a 3-way switch here, 2-way switch here, 3-way switch here. You can have your train sleep in the depot, sleep in the line. It depends on the amount of money you want to spend. There's a lot of options there, and believe me, there's very little required maintenance. The maintenance here is more driven by some of the codes that they have there. The actual there's just a lot of maintenance that you have with trucks, with gearboxes, with wheels that you don't have with this particular technology. Here's various pictures of the Linamo vehicle with a few different paint jobs. I guess this is about the only difference in some of these. Nice looks on this vehicle. You notice here, it's very open, and the beauty of this car really is also from the inside. When you're sitting you're standing in this car, you have a tremendous panoramic view of everything you go by. And to be in a beautiful place like Honolulu and riding in this car, it's going to be a very, very attractive thing from the rider's perspective as far as what you see. Some of the other technologies may have a wheel up front, like a monorail, where you won't be able to see out the front of the car. And this one here is just very open, very, very open approach, and very, very attractive for that standpoint. Reliability and performance. Our partner who's doing the execution side of this, they've never been late in delivering the system, never had safety incidences. We have a system floats above the guideway. There's no moving parts and such in that. Only these brake shoes and power shoes. Very minimal wear. The HSSC levitates and it's propelled silently and very, very quiet. In Nagoya, if you're underneath the guideway, you may not even know the train went by. Now, you see this car with the front that we've had on it. You can also have a different nose. You can have fiberglass nose on this one. It's a little more forward-looking. The one in Nagoya might look a little pedestrian. You know, doing something a little bit fancier, you can have it. And we propose different ones. This is something like what we proposed for Las Vegas, so you can have to focus on the same train. The mechanical part of it is the same, more or less just a nose that would be different in the car. So it can be varied there, or personalized to a different one. So this is an idea of what some of the aesthetics could look like on the inside. What it might look like. And it's something special. I think this is a very special product. Would be in a high-end tourist area like this, I think you may want to consider making sure that you have the opportunity at least to see what would it cost to have this system. What would be an opportunity not to have a limitation. Hopefully that the process will not throw out every other technology that might allow something like this to be to compete for this project. So, initial and life cycle costs, we will be competitive. We have two partners with very, very strong financial backing. We have a terrific passenger experience. It's a quiet system. Its safety and reliability is excellent. We have a proven track record in Nagoya and many other demonstrations of this same technology. We have a superior ride quality, and we can handle a very high volume of passengers.
May I ask a question while we're waiting?
Yes, sure.
You blurted out all kinds of initials, and I'm new to this. Can you tell me what HSS, and I didn't get it?
Sure. HSST, High Speed Surface Transport.
Oh, okay.
But as I said, this system we're proposing, we really consider this an urban maglev. It's more of a medium speed,
Okay.
60 miles per hour, 60 plus miles per hour.
Okay, you also said RFI?
RFI is the process that the city is going through, the request for information. I'm sorry, that's not
okay.
my
I don't know all these.
So the RFI is the request for information that the city has.
And what's
We're having questions. Wait.
I'll hold the questions now. We'll run them. We have a 5-minute video, and then I'll happy to take all the questions.
Okay.
And if we
All right.
run out of time, I'll stay, and we can take any other questions that you may have. We just did the short version of this here. Huh? It's okay. It's fine. It's only 5 minutes.
Where's the volume?
It's as loud as they can make this.
It's terrible.
Okay, I'm sorry for the volume there.
Okay, does anybody have questions?
Question?
Okay, Pat, you identify yourself first.
Patricia Blum, I live in Pacific Cycle. I learned how to get on and off the Long Island Railroad on the subway. There is a space. You have to step. Does this go, the stopping, is it level with the platform?
Excellent question. The station gap actually is covered by the standards that work on automated guided transit, and it's much tighter than the Long Island Railroad. The Long Island Railroad still, even today, when I ride the Long Island Railroad when I go to the New York office, there's always announcements, watch the gap. The issue with the Long Island Railroad is the Long Island Railroad runs at full speed through the station. So that's one of the issues, that they have to have that gap. And of course, it's not. This is built to a tighter standard. It's the ASCE, the Civil Engineering Society standards, and it's a much closer gap control on this. Now, you will not have full speed running through stations on this, especially on automated train. So that's part of that answer. So for wheelchairs and for access, it's very easy, very simple, and very safe, extremely safe. Your feet won't go through the gap. I think this is quite good there. And I don't know what their plan system here is, whether whether it's actually absolutely decided or not, whether it'll be station doors or not. But we had somebody from PP here. Is there station doors for sure? No. So it's still automated guided transit. It'll be closed to cabin control.
Because it's scary.
Okay,
Yes.
yes, go ahead.
Oh,
She's pointing, she
sorry,
can't see.
I can't see, I'm
Oh,
sorry.
sorry.
Yeah.
Sure. Go ahead.
Yeah,
I'll take yours.
Louise Horio, Hui Kupuna VIP Senior Group of Visually Impaired Persons. Sorry, I didn't know all your initials. I have one on the ATO you mentioned. What
Yes.
was that?
Automated train operation.
Okay.
Essentially,
That's
we could say
simple.
that this is a driverless train. There's no driver that sits on the train. There's a control room. There's all kinds of communications to the
Okay.
car, radio, you have closed circuit TV in the stations, lots of different ways, but there's no driver that's in the car. Now, in Japan, we actually go through a tunnel. So there's a Japanese railway requirement that says in a tunnel you must have a driver. So we have a driver. He sits there. He doesn't drive, but he sits there.
Okay, I have two other points and I'll be finished. Yeah, we talked about a little bit about disability rights, you know, to enter and exit safely. Do you have like, you didn't mention anything about locking in the wheelchairs
Yes,
or?
absolutely. There's a requirement in any transit system in the U.S. that it be ADA compliant. This will be ADA
Yes.
compliant. Absolutely no problem. I think probably the system, the Linamo system in Japan would meet the requirements, but it will be built to the U.S. standards of ADA compliance with wheelchair spaces and wheelchair locks and wheelchair distances for access and width.
And what
No
about
problem.
entering in and out? Do the disabled get in and out first? I mean, would that be a question to ask OMPO later?
I don't know. I mean, that would be, I guess,
Yeah,
operational
OMPO.
priority.
Oh, okay, let me get back. One more thing. You mentioned that this train will travel even in snowy conditions.
Uh-huh.
We have lots of wind.
Yeah,
Can you
wind
tell
is no
me-
problem. We actually had a comment, someone had made a comment about whether we could handle the winds, and the standard for which we operate in Japan is very, very similar to the highest winds you have here in practice.
When you say highest winds, can you
Well,
give me a number
I think you're looking at 50, 60 mile an hour winds before you would stop running
to
the
stop
train.
the train? Yeah, because I've been in Las Vegas where even the short ones, they stop everything, so.
In Las Vegas, in fact, Las Vegas has some pretty unique wind conditions, and we're
They want you in the
companies
casino,
where we
not
had-
right?
That's true,
It's a
that's
2-hour
true.
delay. You gotta-
When, perfect. Bob?
Yes.
Hi, I'm with the Canadian
Yes.
Airport Board. I'm very familiar with the Vancouver SkyTrain and the Millennium Edition and the Expo.
Okay.
And it's a that one is driverless also.
Right.
It's electric power, but it's maglev system. My question is, how much electric power is required? More than a regular electrical system?
Well, we have a linear induction motor, which would be very, very comparable to what the SkyTrain would take, because that's also a linear induction motor. Same thing. Linear induction motor may use a little bit more propulsion power, but it's a little better at climbing hills. So you have puts and takes. Maybe most efficient would be very, very efficient electric motor that's back in the circle again. However, then you have transmissions and wheels and wheel squeal and
It
other
has to be, for Hawaii roadways, they're narrow right of ways, so it has to be, in my opinion, it has to be grade separated, the whole system.
Well, we hope that's the decision. Our system is really designed to be grade separated. We really can't run at street level. As you see, our system surrounds the rail, so you can't drive a car over our system. And we think, certainly I think that streetcars are very nice if there's lots of streets and available space for it. And it can be more attractive, in fact, having something lower. Maybe some people like the attractiveness of having it lower, but in a case where you don't want to take up you have no roads to begin with, you have no space on the roads, get it up in the air, keep it
One
up
thing I
in the air.
noticed, the fence you had, it's kind of unsightly, that fence, unlike.
Okay. This is another one of the requirements in building a guideway, and this is the requirement in Japan to have that safety fence, so they have a walkway on each side of the guideway. I agree with you; it's not very attractive, and our system here would have a escape and a walk pathway in the center of the guideway between the two tracks, so it would be wide open on that. So you would not have that fence, and I agree; it's not very attractive.
Another thing, the American dollar has declined so much. I see, Canadian dollar has increased, and I guess even your money in Japan. So I think cost is risen, and I don't know if the planners currently have taken that into consideration.
Yeah, I guess costs have risen everywhere, and anybody's technology that comes here, we have Japanese technology, but anybody's technology that comes here, any train that comes here is going to have a lot of foreign components in it, so there'll be some Euro-based equipment and some of the other suppliers. It's an issue, of course. The U.S. dollar doesn't buy quite as much as it used to.
Okay, the next question.
Next question.
Yeah, real quick, 9 cars running right now in Nagoya?
9 trains.
9 trains?
Maybe 9 trains, 8 trains.
Okay, I saw the number 8, and one of the demonstrations had 9. So I just wanted to know how many.
And we run 3-car trains. Here, maybe it's a 4-car train, depends on how many seats in the car. We were looking at that in the RFI, but it could be a 4-car train here.
Do the cars go?
Daisy, excuse me. Paul,
I'm sorry.
Paul, Daisy?
My question, because it's been a driverless type of system, something like the metro system, I'm not sure if that's driverless, but is there like a specific time that is allotted per station, or is it some kind of mechanism to tell the operator and the control system that we need a little bit more time because we have more passengers or more people with handicap coming? Is there a way that
Well, generally there's an allowance for that in the station dwell time, the time you stop in the station. There's plenty of time to get on the train. Now, of course, if there's someone that's in the door, there are safety protections. There's also closed circuit cameras, so the people in the control room can see if there's a big crowd on the platform, for example. So you have those other kinds of controls, and you can make adjustments for those.
Okay, there is one thing. Like in the Washington Metro system, they have flashing lights to alert you there's a tram coming.
Can't hear you.
There's a, like in the Metro at Washington DC, they have this flashing lights on the platform to alert you that there's a tram coming. Will there be some of the system, like it'd be, say, like a mile away to alert you?
Yeah, I'm not sure exactly how the signaling will work on an approaching train, but yeah, there will be. And I'm not sure what the safety will be. Certainly, it'll be covered according to the safety standards. Next question.
There was a story last week in the Wall Street Journal about protests of over 2,000 people in Shanghai protesting the extension of the existing maglev. And I wondered, and that made me very jealous. And it wasn't quite clear about why it was. I wonder if you knew why.
I heard that mentioned today, but I haven't read it, so I really can't comment. I don't know what the issue was. That's of course a much faster train, so there may be an issue of, just the sound of that train going by. If you're going by at 250 kilometers per hour, you're talking about a very big wind noise. So I don't know what their issue was.
So isn't this one of yours?
It's not our train. No. It's not our train. We're not going at those speeds. We're going 60, maybe 62 miles an hour. That's the top speed on this.
The application for interstate. Our application is urban, maglev, much different from German's maglev.
Yeah.
Different application.
Next question.
Leroy?
Lawyer. Does the train come with its own power system, or does it rely on tapping into the existing infrastructure?
There would be a power station, one or more power stations, more than one, I'd say. There's one in this system. In Nagoya, there's one substation. So it's tapped in. There's one substation. In Honolulu, there'd probably be more than one. It'd be maybe 2, 3 spaced along the route. And
when you say substation, that's tapping into the existing system?
Tapping into the existing system, sure. You have to get your power from somewhere, sure. You have to
Okay.
Hi, Ed.
Yeah, hey,
Richard, morning. I have a question. So the maximum capacity is like 10 times toll road, bus rapid transit, and the time frame to build is like about 5-6 years, you think?
Well, I think if you look at a 4-car train, maybe you're looking at with maybe a nice seating arrangement, 375 people per train. And you can have a headway, you can have every few minutes, you can have a train go by.
20,000 people.
So you're talking about moving a lot more than what you probably would with bus rapid transit. The throughputs can be very substantially higher, but of course, if you have 1 million buses, you can have a lot of people.
Gil?
Gil Riviere, North Shore Chamber of Commerce. Would there be 2 tracks the whole way? Or would there be one and then they kind of go around each other?
Yeah, there would be. I think I can write with this thing here. Generally, these systems are run in what's called a pinch loop. So it runs in one direction, and then maybe before or after, here's the station, maybe before or after the station, it will transfer over. You saw one of those switches, and it'll run back the other way. So they're sort of double-nosed trains that run the other way. So it's they call that a pinch loop, so it'll run like that. And the same thing on the other side, it could come back the other way, and you can also have crossovers. One question I know I've had from some people ask about, can you have an express train, that kind of thing. The station, passing through the station, if there's not an offline station, you generally are at slow speeds going through the station because of the reason of the safety, the gap safety there. So you have to run at slow speeds through stations, so you don't gain so much by having an express train. But we can run at 60 plus miles an hour, so we can make this, the spec on this is 40 minutes end to end on the first leg, and that's what we're looking at meeting, is that 40 minutes end to end.
Scott?
Given your understanding of the projected layout of this fixed guideway and the conservatively predicted or projected transit stops, what's the maximum speed you expect this technology to be able to reach between the ideal two transit stations?
It will reach that 62 miles an hour, maybe 7 times end to end. It'll get up to that speed, maybe 7 times.
Just so I can kind of have something from my memory, is there a specific 2 stops where you could cite that from your research so I can just kind of remember that in a decade?
Take the longest distances between the 2 stations. You're going to be at 60 plus miles an hour.
Okay.
You're looking at 2.5 miles per hour per second. So that's the acceleration rate. So if you can do the math on that, acceleration times time, you can get to how long it takes. About 10 seconds, I guess, to get up to speed.
Gentlemen?
Behind Tom.
Tom. Yeah.
Yeah, I have a few questions.
Yeah.
What's the size of your single substation that you're running? What size did you expect with a P2P substation?
I can't quote that off the top of my head, but I can get that information for you. Certainly get that information for you. I think the RFI, which is coming in a week or so, has got information on the substation.
Okay, so you're responding.
Yeah, so that's coming. That's forthcoming.
What's the width of your car?
It's meters, 2.5 meters. It's like standard width, pretty much standard width car.
And can
45 feet
Can the
long.
passengers go through the entire train?
Sorry?
Car to car?
The
You permit movement from, you've got a 3-car train here, and the passengers.
You have, yeah, you
distribute
have
the load
passengers.
between cars and passengers.
Absolutely, right. And you have egress at the nose and the tail end for emergency egress. You have that as well.
Do you have a detection system for, at the platforms for incursion into the right of way?
Platform screen doors. I mean, of
No,
course we.
no. If you don't have platform screen doors, which you don't apparently have in Nagoya, or do
No.
you?
No.
No. Then how do you detect the incursion into the right of way?
Well, I mean, I think we can apply whatever technology is specified for an automated guided transit system.
Well, I know, for example, Vancouver has a detection system for an incursion into the right of way.
Yeah, there's no reason why we can't
But you don't
apply
have
similar
one in Nagoya,
technology.
you haven't provided one yet?
Yeah, I don't know. I'd have to give you a more
Yeah,
specific
we have
answer.
only first station, the end station. We have protection, but that is depend on the client requirement. The technology is not difficult, you know. If client request, we can provide, you know.
But you haven't done?
Nagoya, in Nagoya case, client didn't require only 2 stations, but other station we don't have.
Have you done any development of
I understand your question. I think
existing.
let me get our technical guy to give you an answer on that one there. As far as
Could
whether we
you-
have any best.
Could you identify yourself?
I'm Mike Becker with PB Americas.
Okay.
Other questions?
One more question.
Oh,
Wait a minute, 2 maybe.
NFPA 130.
Yes, we will comply.
You will comply.
Right. And as I said, we'll have the center egress, the center platform for walking along the guideway. We won't have these outside platforms with the ugly railings. So you'll be able to see the train instead of the railing. Yeah.
One more, over.
Should say
So
ugly.
roughly the
That's
sound
attractive.
level of rubber tire and maglev would be like 1/4 the noise is No
Well,
noise at all.
That's hard, it was just measured in decibels,
Yeah.
so not 1/4. I think we're at maximum in the 60 decibel area.
Yeah.
Very quiet. In Nagoya, honestly, if you're underneath that guideway, you don't even know the train goes by. It's
If you have
very,
a
very
rubber
quiet.
tire, you're hearing it like blocks away.
Rubber tire, you might, yeah. Steel
Like a
wheel,
bus.
you can have wheels squeal, but you know, the modern trains are more quiet, but certainly more quiet. We definitely feel we are quiet. We are a green train from that aspect for the sound.
AARP has the last question.
Oh, thank
Okay.
you. I'm interested in how many seats you can have in one of the cars. I'm just, obviously, AARP, I'm concerned that
Sure.
if most of the people have to stand, that creates certain problems for someone else.
Sure. Of course, we will provide as many seats as you want. You can make the whole thing full of seats.
Okay.
And if you look at the picture, I think there might have been an interior picture, and I believe there's one in the brochure here. I'll show you that. You can have it fitted out for 75 people or maybe 95 people, that same long car.
Okay.
So it just depends on how many seats you have. You know, if you want to be like a subway where you just have side seats and everybody stands in the middle, you can do it that way. Very simple, it's cheaper, but and you can get more throughput. But if you want more seats, you can have more seats.
Thank you very much.
Thank you very much. Thank you very much.
Other business, suggestions for future agenda. Has anybody got at this point? Okay.
Charles?
Yeah?
You might remember that we wanted to rebut the smart growth presentation that was made by
Go ahead.
Yes, you're required to follow the agenda. I believe you skipped an item.
Okay. Excuse me. Scott Belfour is the chair of the subcommittee on TVP.
Maybe if you give me a card, I can give you an answer to it.
I know. You're supposed to. Okay.
Thank you, Scott. The subcommittee's purpose was to basically study how the CAC can best help the policy committee in its advice regarding public-private partnership. In regards to that particular direction, I thought it best, in order to figure out how best to advise the policy committee, to ask the policy committee chair directly, what can the CAC do to help? I talked with the chair, Senator Willis Farrell, and what he said was basically two items. One, first of all, he appreciated the CAC's past efforts in regards to what the CAC had done at their October 22nd meeting, which was the reminder of the public-private partnership guidelines, and also
email was correct,
the policy committee urged the Senate Transportation Committee to hold hearings on the House Bill 70. During that particular discussion, the policy committee chair, Willis Farrell, indicated that he considered this bill to be worthy. He introduced a similar bill on this particular matter, and that he had discussed House Bill 70 with Senator English several times himself. He also felt that the policy committee at that particular meeting decided to let this issue be decided in the legislative arena. This discussion at the policy committee is described in our minutes, and it's about 2 pages long. There was a pretty elaborate discussion at our policy committee. The second thing that he wanted to point out was that the fate of the public-private partnership is in the hands of the legislature. He said that the policy committee does not wish to continue discussions on the public-private partnership, acknowledging that the legislature will have the final say. He said that the legislative members on the policy committee will take what they heard at the policy committee with regards to the discussions, and they will be bringing that with them when they deliberate on this particular issue at the legislature. Those were the 2 points he wanted to make. One, he appreciated the CAC's efforts, and two, that the fate of public-private partnership will be in the hands of the legislature. A little background or perspective from my point of view is that there is sometimes a frustration on the part of the public, especially when they deal with our organization, and that deals with what can the policy committee member do. With regards to the policy committee's action on activities that they have jurisdiction on, such as the Transportation Equipment Program, the Regional Transportation Plan, they can do a lot. But where they do not have the jurisdiction for a certain activity, such as public-private partnership, it becomes very difficult for them to initiate any major significant action. And that's why the chair has indicated that the public-private partnership issue will be resolved at the legislative arena. One of the things that also frustrates the public and some of our CAC members is that when they see a member of the legislature sitting on a policy committee, such as Senator Willis Barrow, they see him as a senator, not as a policy committee member. When they sit on a table as a policy committee member, they are acting as a policy committee member, not as a state legislator, so that they cannot initiate legislative actions. With that, I'd like to turn it over to Scott.
Thank you, Chair.
Right.
So, I was not here this last month in December when this committee was formed, but I do have a keen interest, and so I have volunteered to be a part of this subcommittee. We met, as you've been told, and I think that you would be interested to know that we had a very good discussion, and the consensus was that were we to have any outcome from this subcommittee, it should be a pro and con report concerning PPPs and with respect to transportation, and that we should try to get this out before April so that were there to be actionable items from our research, elected officials may have the benefit to review these items and maybe incorporate them into this session. And this made, I think, good sense in principle. I think we were pretty clear that we wanted to avoid stroking any past fires with respect to advancing particular pieces of legislation, and instead wanted to be certain that we honored our role as objective, professional members of the public presenting both sides of an issue. However, I will, I guess, comment on what we've just learned about Chair Sparrow's comment, is that at the time we were probably of the belief that since a policy committee was comprised of elected officials, that this was an appropriate venue to say, hey, here's some data and information. I think that what's just been explained, we didn't really necessarily understand that. But that was the outcome, and I think it was a good, positive, professional, proactive outcome with good goals. And I guess we're going to maybe need to reconsider if we meet again, because it could be that the best thing we can do individually, given that each individual represents their own respective constituents, the individuals in this room may want to find themselves reaching out to their own elected officials. And so that's my report, my comment, my reaction to what we've learned today. And I would take any questions if that's appropriate, or otherwise turn it over.
Any questions?
A question, Mr. Chair. Given that the committee, the subcommittee's purpose was to provide you with information to present to the policy committee, the talk of getting something out by April to present to legislators is beyond the scope of the subcommittee. But the idea of presenting pro and con issues to this committee is laudable, and I think that's pretty good.
I think we can do that.
Charles?
Yes. Cliff?
I don't know if everybody's aware, but the legislation is not the only way to handle this. FHWA is encouraging states to apply for the funding that they have available now, whether or not they have the legislation in place. They think that it will be a way to encourage legislation. So this body could encourage Hawaii DOT to apply for some of the experimental funding.
Well, I think what they propose, the subcommittee, is they'll come up with the pros and cons first, and then we can decide on what to do with it.
Yeah, and I misspoke, and I appreciate that clarification. Our duty is actually to report back to this group. I think I was cutting to the quick and being crass and saying if there's any actionable output from this, it would be that somebody could pick and choose this session. But obviously, we should report back and allow.
And of course, individually, each organization can go to the legislature based on these pros and cons. Okay. Is there any other discussion on this point?
Just one.
Oh, I was wondering why.
With regards to DOT submitting an application for public-private partnership, that activity, I believe, has been done at a certain level. The state DOT, a representative from the state DOT, Federal Highway Administration, and myself attended a workshop in Minnesota back in November. In this particular workshop, it was to basically promote, not to study why you can or can't do something, but to push for a toll type of facility. Based upon that particular discussion, it also boiled down to the need for this legislative action to occur before this thing could pursue. So there is interest on the state DOT's part. However, the legislation is very critical, and again, everything boils down to what happens at the legislature.
Chair, that's if I can say.
Go ahead.
Gordon, you're talking about something a little different than what I'm talking about. The state can apply for some of the FHWA funding, experimental funding, okay, without having legislation in place. Hawaii DOT has not applied for that funding.
What I said was, on a related matter, that the state DOT had actually done something similar. That there were actually 5 cities that actually approached the Federal Highway Administration to actively pursue a toll facility project. Implement a toll facility project.
Right.
All right, I'd like to go on to other business. Future agendas, suggestions for future agendas.
I have one.
Go ahead.
Do we have DTS give us an update on the rapid transit project, fixed skyway project?
Could be done.
We haven't had an update for a while.
Okay. Anything else?
Right here.
Chair.
Oh, yeah.
I've been asked by my community to bring before the OMPO the need for, and this is the Waianae Coast community, the need for an emergency alternative route for our folks with the recent down utility lines. We were trapped. We had no way in and out of there. The Coley Pass was shut down by the military. There were several days that people were unable to even get to their jobs. This has come before this committee before yes. the organization. The organization has since also said that there is definitely a need for this. I would like this to be brought up again, and for the state DOT to take action. I would like them to come before us and tell us why they haven't.
I forgot to make a request to everyone in here. Our first subcommittee meeting, Mr. Chair, was maybe more positive around PPPs. So if anyone has any con or any kind of negative arguments, we're going to facilitate a contra discussion next month. So Scott with 2 T's at belford.net, and I can integrate that.
Okay.
Another item.
Yeah.
We have moved on to what we call other business, and the item that was just being discussed was under new business. We don't go back to business that's already been done. I might add that I've noticed in the discussions we've had, you're having a single person speak multiple times.
That there were certain items that he would like to pursue. As a result of, I guess, the past couple of meetings where there seemed to be a series of motions under other business, under announcements, indicating a desire to have some topic discussed at the Citizens Advisory Committee meeting. A format was set up on your agenda, as was explained, I believe, a couple of meetings ago, that under the other business, sensing that there was a desire to identify needs from the CAC on topics, and that apparently the survey that was done earlier was not being used, we did not want to circumvent the desires of the CAC members by not allowing for this type of interaction. So this agenda item was created to allow the CAC members to bring out topics that they thought would be appropriate. And that's why it's on the agenda now.
So we negated all the work we did?
No, the survey is still valid.
These are additional.
Yeah.
Okay, well, if given a revote, we want the ones we put on previously that have been placed on the agenda.
Can we move on to the...
Charles, could I ask a question? I'm confused.
Yeah.
Is it accurate to say that you are the one basically that determines the next agenda? Is that a correct statement?
Unless it's a motion put on by the CAC, I do have some control over it. Okay.
And was the list that was voted on, that would not be considered something that was a motion?
No.
Survey.
Okay. Can we move on to Oahu MPO meeting highlights? Marion?
This month we had a meeting of both the Policy Committee and the Technical Advisory Committee. The Policy Committee met on Monday, January 7th. At that meeting, the Policy Committee approved the revisions to the fiscal years 2008-2011 Transportation Improvement Program. They also heard the results of the Metropolitan and statewide certification review and heard highlights of the November and December CAC meetings provided by your chair. The Technical Advisory Committee met on Friday, January 4th. At that meeting, they made a recommendation to the Policy Committee on the revision number 3 to the fiscal year 2008 to 2011 TIP, and they also heard results of the Metropolitan and statewide certification review. And there's no future meetings scheduled at this time.
Okay. Are there any announcements that members want to make in regards announcements from the floor, meetings and such? Hearing none, I would call for an adjournment. Does anybody want to pass a motion?
I move to adjourn.
With no objection.
With no objection.
Meeting will be adjourned.
Yeah, okay, adjourned. Okay. That makes it easy.
I doubt if you pass it, that time will be good.
Yeah.
I have a couple of minutes before I get them out, but I have.
How are you, sir?
What were they doing on, what was that protest?
Yes.
They wouldn't do that here. They wouldn't do that here. Can you get 25
Give us a presentation as to why you're
Based on my experience as a chair, you can never tell somebody, I took your list, read it, decided I didn't. Okay, this applies not from a parliamentarian, but from anyone here chair. You always say, well, we'll go back and look at that again and consider which ones are not yet. Doesn't mean you put them off.
Okay, very good, because I'm going to be so he's been giving me a lot of administration. So it'd be good
Maybe I should say, as all young people, maybe I should say, I got my
yeah.
We used to be better.
This is not my time.
They're good people and I don't like
Hey.
touching and prodding.
I have about 9 years. So what are you doing?